Problem 5. Create a new function file and write a function, and v equals count invalid values, a, b, that takes in 2 row vectors, so a and b here are vectors, of varying lengths. So varying lengths means they can be any size, arbitrary size. It doesn't say they have to be the same size, it just means they are varying lengths. And returns the following. So n is the number of values that are above 75% of the maximum, and below 25 the maximum values in B. So here some values in A, and some values from B. So I have some values from A to grab, some values from B to grab, so that means I'm going to do concatenation in order to fill N. And then V, but it's filled with, oh, no, it's not. I'm not going to do concatenation. I'm summing. I'm counting some of the values in A and counting some of the values in B. For V, the values in A, so here's a number of values. For V, it's the values in A that are 75 for the maximum and values in B. So here's where I would do concatenation. That says concatenation if you didn't know. And then it says do not use loops and do not use branching. If I'm not using loops or branching and I'm dealing with vectors, that means I'm using logical indexing. So let's go ahead and look at how this program's out. So it's a function. So a function and B, once again, you can technically call these whatever you want. Count invalid values. A, B. This one does not say I need comments, so I'm not going to go ahead and waste my time on comments. Okay, so N is the number of values that are above 75% of the maximum value in A and below 25% of the maximum value in B. So I need to figure out the maximum value in A and the maximum value in B. So max A is going to be max A. Max B equals max B. If you don't know how to find what function uses what function to use the maximum for, just search the documentation. Calculate maximum value. Okay, A and B are vectors, so it's gonna find the maximum value in the entire vector. Okay, then it says N is the number of values that are 75% above the maximum value in A and below 25% of the maximum value in B. If I want to find the values, if I want to count the number of values in A that are above 25% of the max, it would look like this. So the number in A is going to be sum A greater than 75%, so 0.05 times max A. So it's going to take A greater than 75% the max. This is going to be my logical indexing. I'm essentially saying which values are above 75% the max. This gives me a bunch of answers, ones and zeros. If I sum them up, it just counts all the ones. So the number of values in B are sum B less than 25% the max. Which means N is going to be NA plus NB. Here I've got the number of values that are below 25% the max in B, the number of values that are above 75% of the max in A. If I want the values in A that are above 25% or 75% the max, I would say A greater than 0.75 times max A. This is where I'm saying which values in A. It's kind of like saying A 1 to 4. Grab the values in A in locations 1 to 4. But now, instead of it being specific locations, like always run in 1 to 4, now I'm saying grab only the ones where A is greater than 75% of the max. Same idea for B. So grab only the values in B where B is less than 25% of the max. Okay, so this is the same idea as normal indexing, where we'd say A 1 to 4, but we don't have 1 to 4 anymore. We want to say just grab the specific ones that are above 20 or 75% of the max. So here's how you would count values. Here's how you would grab the values, which means V is going to be the values VA next to VB. I'm concatenating them together. I've done something. I can go ahead and test it. Remember, you can't run a function file. You have to call it from your command window. So I can say A is rand I. It's a vector, specifically row vectors. So we'll say the maximum value overall is going to be 10. One row, 7 values, whatever you want. So there's A. Here's B. So 75% of 10 is 75 or 7.5. So there's only one value in here that's above 75% of the max. 25% of 9 is something around 2. So there's only one in here that's below there. So if we went ahead and called our function, n is 2, because there's one here and one here, and then it's 10 and 1. You can call it with different values. You can see, okay, 10, once again, anything above 7.5. Down here, anything below 2. So same boring numbers, 2, 10, and 1. That's just the way that it happened. If we test it one more time, so max here is 8, so 75% of the 8 is a 6, so anything above 6. And anything below a 2.5. So here now I have 3 values. I have one here, and one here, and it grabs those. So you can go ahead and test it with different values. You can also mark out what you want your values to be. So you can say A equals 1, 2, 3, 4. B equals, you can make those different. So 4, 4. B is 1, 1, 2, 3. And then you can go ahead and figure out what those should be. So N, max of A here is 4. Which means 75% of the max is going to be 3. Max here is, I'll make it 4. Which means 25% of the max is going to be 1. So maybe I'll make these 0 and 0. Then you can go ahead and see, okay, 1, 2, 3, 4. The answer should be 4, and then B should contain 4, 4, 0, 0. So you can go ahead and type that in as well. A equals 1, 2, 4, 4. B equals 0, 0, 2, 4. And then you can call your function again, and you can see whether or not it matches what you expected on your paper. So this one is a little bit more complicated, but these are the ideas behind logical indexing. If you're ever told to count something or find the values of something, and you're told not to use loops or branches, that means you're using logical